In this Algebra 1 video, we're in Chapter 5, Lesson 4. We're going to talk about solving compound inequalities. Now, I'm going to go into more detail explaining the what is that and everything, but for now, let's just write this down, let's get organized, and I'm going to explain it in just a moment. Our objective is, as the student, I can solve and graph or, I know it sounds weird how to say or, but there's two types of compound inequalities. There are compound inequalities, and there are or compound inequalities. I promise you we'll define them and talk about how to tell the difference. Anyways, I will solve and graph those because I will solve both parts, because by the way, there's going to be two parts instead of just one part like we're used to. And I'm going to check to see if they overlap or not. And sometimes whether they overlap, it means something. So in general, these are the two most common forms. You have your and compound inequality. It is going to look like this, and I will do a more in-depth this in a minute, but basically what it's saying is, I'm just going to make this up, this is just a made-up example, x is greater than or equal to 5, and, literally the word and, x is less than or equal to 10. So now, made-up example, I'm just giving you an idea. So if it's greater than or equal to 5, that means go to 5, put a solid dot. Greater than or equal to is everything to the right. Now, if it's less than or equal to 10, we would go to 10, we'd put a solid dot, and it's everything to the left of 10. But it says and, meaning it has to satisfy both. So the only place where it is true for both is right here between 5 and 10. Only this area in between satisfies both. So that's what I mean by an and inequality. It's all about where does it satisfy both of your inequalities, because in one question you're going to have two, such as the two I just wrote. Okay? And now I realize I'm already starting to explain what I wanted to explain in a second from now, but basically it's all about where they overlap. That's what's important for the and compound inequalities. Well, an or inequality is going to be just like what I just wrote, but instead of the word and, they're going to use the word or, meaning either or is a solution. So generally, not always, because I will give you examples in this video where it's not like that, where I try to do all the possible combinations. In general, I'm just making this up again, if it was something like x is less than or equal to 5, and x is greater than or equal to 10. I know that's messy, but basically what that's saying is go to 5, and it's a solid circle because it's equal to, less than is everything to the left. Go to 10, solid circle because it's or equal to, everything to the right. Well look, in this case they never overlap, okay? But this whole area and this whole area, everything to the right, everything to the left, all that is still in the solution, both of those areas, because it says or, meaning either or. Anything in either of those locations is a solution. So it's not necessarily where they overlap. However, or compound inequalities can overlap, and you pay attention to some of it, and I'll show you about that when we get to it. I will do an example where it does that. So I'm going to make an effort to show you an example of every single one, and there's of course going to be some you-try questions. All right, so let's get to that. Let's get to that vocabulary stuff real fast. I want to make sure I mentioned. I kind of already did on accident, throw it in there, but just to be super clear, basically a compound inequality has two or more constraints. An example would be here. There's two constraints. Sometimes it's usually so p minus 5. Well, okay, negative 3 is less than that, but also p minus 5 is less than 2. So there's two constraints instead of just one. Or they'll literally use the word and. That happens very often. You don't need to write these down yet, by the way. We'll get to them. Or in this case, it looks more complicated, and I'm going to show you how to break this one down. Or they will literally use the word or to let you know that there's two. Most of the time, the or inequalities, they're going to use the word or. Technically, they could just give you something. You wouldn't know it was an or until you kind of solved it a little bit to see the solution. All right, so we'll get to each of these. I don't necessarily want you to write them down. Okay, so those are some examples. So how can you tell? The thing that I want, so if let's say it was a word problem, okay, especially in a word problem is where it's not clear. When it's not a word problem, they'll almost always use those words, the word and or the word or, so you can tell. But if you're not sure, the and inequalities is going to be implied by if it has to satisfy both. So if it's saying it has to be true for both of the restrictions. Like I mentioned, greater than one of them or less than the other one, but where it satisfies both is what's right in between. Whereas an or inequality or situation is where if it just satisfies either of them, and we will do an example of that. So quick glance, this word problem we're going to do, basically the signs can be higher than the power lines or the signs can be less than the power lines. They can be either or. However, they cannot be what's in between because that's in the way of the power lines. So this is an example of an or situation in real life. And we'll get to that one. Again, I want you to write these down. All right, so now we're going to jump into some examples. Okay, so write down this example, and yes, this is going to be an and inequality. And if you're not sure, or let's say it wasn't given, I'm going to show you how you go through how you're going to be able to tell for sure it is an and inequality. But basically, you could assume it's an and inequality because when they write it like this, when they write two of them at once, it's going to be in a situation where it's going to be, you're going to solve this one, and you're going to solve this one. So there's two, and you'll notice what will happen with those solutions. Anyways, let me stop giving you a bunch of side comments. Let's actually do it. All right, there's a preference. There's two ways of how to solve these. I'm going to show you both ways, and I'm going to let you choose. The second way takes maybe, God forbid, an extra 4 seconds, but a lot of people like it because it's a little bit more organized, but it's up to you. Here's what I'm going to show you. I'm actually going to do the second way first, and I know that sounds weird, second way first. In other words, let me show you one way. One way is this. We're going to write this down. We're going to write that inequality because that is one of them. So you can write them separately and solve them separately. So you can say negative 3 is less than or equal to p minus 5. Well, we learned how to solve this in our last video. Basically, you add 5 to both sides. Use your negative skills to make sure you know what that equals. So negative 3 plus 5, well, that hopefully is positive 2. If not, I'm going to retire. All right. Anyways, so 2 is less than or equal to p. That is your answer, although it is proper to put p on the left side. So make sure the alligator follows the p. So this is one of your answers to this question. However, we got to do the other half. That's this method. So now we got to solve the other half. So basically, I'm just going to write that down. I'm going to write down the other half, and then that's when we're going to solve. So p minus 5 is less than 2. So now, same exact thing. You're going to add 5 to both sides. And once you do that, you're going to be left with p is less than 7. So you now have your two answers. You have p is greater than or equal to 2, and p is less than 7. Here's what you're going to do. You're literally going to graph both of these on the same number line. But graphing them is the same for no matter how you do it. But now I'm going to show you the other preference. So if you like this way, great. Or you can do it slightly different. I'm going to hit pause and set that up. Some people, when they have these, they like to solve them simultaneously, meaning they know that in order to get p by itself, regardless, you're going to have to get rid of minus 5. So what they do is they solve them all at once, meaning it's kind of going from the inside out. So they add 5 out here, and they go ahead and do it to this one because they realize to solve this, you're going to have to get p by itself. You're going to have to do it to all of them. So you're basically going inside out. So it's almost like you're getting that 5 to both outsides. Kind of like you're fighting a battle on two fronts rather than just one equal sign. So they set it up like this, and then they just now drop down their answer. So they're going to be left with p is less than 7. They're left with 2 is less than or equal to p. So their answer is already in the form. It's written in the full form of compound inequalities. This and these mean the same thing. But the only difference is they wrote it all in one. And what they're saying is 2 is smaller than p, okay? Meaning that implies p is bigger than 2, okay? But p is smaller than 7. So the visual of, let's now graph this to put it all together. Do a quick sketch, drop down your graph. I'm going to hit pause while I draw those numbers. Do the same. All right, there's my beautiful number line. Okay, so to graph these, p is greater than or equal to 2. You could look at this and see that by kind of imagining p was bigger than 2 because the alligator is eating the p. So you could do it that way, or you could just rewrite it like this to see the alligator is eating the p. So the p is bigger than 2, but it's or equal to. So that means it's a closed circle, okay? And so it says greater than, so everything to the right, okay? So now let's look at the other one. P is less than 7. Well, p is less than 7, so I'm going to do that in different colors so we can see it. P is less than 7. I'll even add a different color here. So that's an open circle, and this one is shaded to the left. Now, because this is an and inequality, meaning it has to satisfy both, the only location that satisfies both is where these just now overlapped. So this area right in between. So your answer is your answer includes positive 2, okay? Your answer is positive 2 all the way up to everything just below 7. It does not include 7 because it did not say or equal to. So your answer is only the things in between. So technically on your final answer, you should not have this stuff drawn because it's technically not there. So I'm kind of making it a dotted line. Kind of like my sketch I did on that first page. I just showed you a dotted line where it is kind of there, but it's not a part of your answer. Your answer is only the shaded region. This is the full graph of this compound inequality. Write down this example. And this one, you can tell that this one is an and because it uses the word and just like that. So you can tell that that one is an and inequality. So they already wrote it separately for you. So go ahead and just solve both of these using the skills we learned in last section. Add 1 to both sides. For this one, you're going to subtract 2 from both sides. So now just write down what that equals and you're going to graph that response. Alright, so these are your two answers. Now graph them on the same number line. Alright, so my number line's huge, it's big and proud. So now less than 3. Less than 3, that's an open circle. Everything less than is to the left. Now, for greater than or equal to -1, well that is a closed circle. And then it says greater than, so that's everything to the right. Okay, because this is an and inequality, it's what satisfies both locations. So this one happened to do the exact same thing. It's only going to be this area right here in between. This is your solution. Your solution does not include what's outside of here. So I'm kind of making it in a dotted line. So it does not include that stuff, but that's how we found the shaded region. Alright, now you're going to try one. I recommend that you take the time to write this as the two separate ones. They look kind of hard when they're like this, so when that happens, I recommend that you write down the left one, then write down the right one, and solve them separately. And yeah, you have a variable on both sides. Do what you would normally do for an equation with a variable on both sides. Alright, hit pause and try this one. Okay, so I wrote mine separately. So now go through and solve these just like you would. Normally when you have a variable on both sides, we made up that method called the mutant chicken method. It says we should, you don't have to, but you should start by moving your bigger variable towards your smaller one. Well, I'm sorry, your smaller one towards your bigger one. So if we subtract positive d from both sides, so subtract d from both sides, you're gonna be able to cancel these out, and you're gonna be left with -3 is less than 6d minus 1d, well that's 5d plus 12. Now I think you can take it from here. And so you end up with -3 is less than d. Well, remember, that's going to have writing our letter on the left. So that means we have d. The alligator follows the d. So if -3 is smaller than d, that means d is bigger than -3. Okay, so this is your answer to the first part of this inequality. Now do the same thing for the right side. Move your smaller variable towards your bigger variable. Now just get away from d. And you end up with d is less than 5. Okay, so now just graph both these answers on the same number line and you're good. Now, I know that Doceri logo tends to pop up down here somewhere, so bear with me and try to listen to what I'm saying if you can't quite see it fully. But I'm going to go ahead and graph it down here. So sketch out your number line. So I went ahead and labeled mine out with only basically the number range that we needed, and now we're ready to graph our answers. Okay, so if d is greater than -3, that means go to -3, open circle, it's everything to the right, 'cause it says greater than. Now, if d must also be less than 5, all right, so I'm going to go to 5, open circle for the same reason as the last one, and it's everything to the left. Now, the only place where they overlap, because it says and, I mean it has to satisfy both, is this area in between. So it needs to be shaded in this area in between, and you'll have two open circles. So that means what's out here doesn't need to be there. You don't need that stuff. So it's just the two open circles and everything in between. And so your answer does not include -3 or 5 because it's an open circle, but it's everything in between. That's the answer to this compound inequality. So now copy down this example, and in this example, the giveaway that it's an OR type is, look, it says OR. So you should be able to tell what type it is. Alright, so what we're going to do is you're going to solve both of these separately. Simple as that, and then graph the answers on the same graph. Now you notice this one on the right, there's nothing to solve. It's already done. The answer is p is less than 2. So you just need to solve the one on the left. Alright, so we got to get rid of this negative coefficient. Now, the only thing you got to remember is you got to remember this is going to activate the special rule. What happens when you multiply both sides by a negative? We learned in the last video that, yeah, it cancels. That's no big deal. But what happens is this inequality sign that I just wrote, it flips, okay? So it's going to become greater than or equal to. Now on the right side, negative divided by negative is a positive. 12 divided by 3 is 4. So P is greater than or equal to 4. So these are our two answers that we need to graph on the same number line. So sketch out your number line. Alright, so once you have your number line drawn, you're ready to go ahead and graph the results. So our first one, it says P is greater than or equal to 4. Well, that means a closed circle, okay, so filled in circle. It says greater than, and greater than means going to the right. So that one shades to the right. Now our other one, P is less than 2. So that's an open circle because it does not include 2. It says less than, so everything to the right. Or, excuse me, to the left. So now you've got your graph. You've graphed this inequality, and now you'll notice these do not intersect. They do not cross. So this is an OR inequality, meaning it's anything that satisfies either of those. So basically, the name of the solution of an OR compound inequality is technically called a union, meaning it's a fancy word for saying union, intersection, because on the last ones we were doing, we had intersections, they overlapped. But on these, they do not overlap. But they want us to include everything because it says or. So this is the answer or this is the answer. They're both part of the answer. Either or would make it true. So a union is when you just say the answers to both. Everything for both possibilities, just include them both. That's it. Whereas for the intersection, it's only about where they overlap. All right. So this was one example. Let's try another one. All right, so take a hint to take a moment to copy down this example and go ahead and solve it. You already know how to solve this, but then I want you to graph your results and kind of check them. So even though it says example, it's almost a little bit of a you try. Go ahead and see how you can do with it. And so yes, it is an or one. Now let's go ahead and rewrite that so the letters on the left. Alright, so now graph your results for this one, and you're going to notice something kind of special is going to happen. It says W is greater than 1. Okay, so greater than is open circle, greater than is to the right. Okay, so there's the shading in the first one. Now, for the second one, W is greater than or equal to 3. Alright, so let's see. That means a closed circle, and then greater than means go to the right. So look, we have overlapping, but it's going to be slightly different than an and compound inequality. I'll show you both. This could have been both. It could have been one or the other, and the answer does change. You'll notice it's what is in this or this. Well, if you'll notice, this one and everything to the right, that includes everything for this or this. It includes both already. So the answer to this question truly is just simply W is greater than 1, because W is greater than 1 includes the answer to the first one, but it also includes all of the answer for the second one. It's already in its range, so you don't need to write both. So technically, the correct final answer is this. You would say W is greater than 1. That's your correct answer to this. That's what I mean when they overlap. Now, if this had been an AND function, let's pretend this had been, they'd use the word AND. I'm going to erase this. You don't necessarily have to write this. It's kind of an experiment. If this had been an AND function, meaning where does it satisfy both, it would only satisfy both where they overlap. So it would just be this area. So it would basically be all of the blue one. That would be the correct answer if it was an AND function. So that would be your solution. So if you were to write your solution down, it would be this. It would not include this if it was an AND function. Okay, so take a moment to copy down this example. This is going to be your next one. And yes, this is going to be an OR inequality because they used the word OR. They gave it away like that. All right, so go ahead and solve both of these. And you'll notice I'm not giving as much explanation as usual for these because these are now becoming things we've seen before and we've done before. Alright, so the first one is going to make you review how to get rid of a rational coefficient. Hit pause if you haven't done so already. The second one, you've got a variable on both sides, so you'll have to move them all to one side first, just like we've done before in the past with equations and with inequalities. So basically, to get rid of a rational coefficient, you divide both sides by that by the coefficient as usual. But here's the thing: you got to remember how to divide by a fraction. So you're left with n is greater than. Now, when you divide by a fraction, remember you put that number over 1 and then you multiply by the reciprocal of what you're dividing by. That's the key to these. So find out what this equals, and that's your answer. And you end up with n is greater than -4. All right. Now take a moment to solve the second one. Your hint is move your variables to the same side first. All right. Subtract n from both sides. Those cancel. And now 2n minus 1n. Well, that's 1n. Honestly, you just leave it as n at this point if you wanted to. So just drop everything else down. Okay, now it normally would be a two-step equation, but since this coefficient is a 1, it's going to end up being a one-step equation. Go ahead and finish from here. Alright, so you end up with n is less than 8. So take a moment to graph these results, and you'll be good to go. And this is going to be a slightly special situation, but graph it first. It's only special because it's an or, and it's not an and. You're going to see something happening here. Okay, so draw out your number line. Excuse me. So once you do this, now graph each of these results. You've got n is greater than -4. That does not include -4, so it's an open circle. It says greater than, so it's everything to the right. I'm going all the way up to infinity. Now, the second one, n is less than 8. Well, okay, that is a open circle again, but now this one is everything to the left. And it goes on into -infinity. So, because this is an OR function, specifically because it's an OR function, it's anything that satisfies this all the way up to positive infinity. It's anything that satisfies this. You'll notice that covers every number out there. It covers -infinity to positive infinity. So because of that, the answer to this question is technically, it's technically all real numbers. Remember that fancy symbol we learned a while back? We mentioned for all real numbers. It kind of looks like an R, but it's got like a double bar for that vertical portion. That's the answer. The answer is all real numbers. Or feel free to just write it out. Feel free to write all real numbers. That's technically the answer to this question. Everything is a solution. But when you graph it, you basically should have everything shaded. So when you graph it, you could draw, I guess, shading for everything on your graph and show arrows going off into positive infinity, negative infinity. So this was a slightly special situation because it was an OR. If this had said and, you don't have to write this down. If this had said and, it only would have included what was in the middle if it had said and. But it wasn't, so we're not doing that. Alright guys, so this was basically our last main example. I was going to show you a quick word problem. I kind of already sampled it to you earlier, just to show you with word problems, you kind of read through and you got to figure out if it's an and or an or based on does it have to satisfy both or is it one or the other. Copy this one down. Alright, so for this, I don't necessarily want you to copy this down. This is going to be straight from one of your assignments. But basically, I just wanted you to see real fast what I mean by if it doesn't tell you which one's which, you kind of can figure out which it's going to be. So, in Randy's town, street side signs themselves must be exactly 8 feet high, meaning the little height of the sign is going to be 8 feet, is basically what they're saying. So all signs are the same height. When mounted on poles, the signs must be shorter than 20 feet, meaning I think that they're assuming that the power lines are at the 20 feet mark, so they've got to be less than 20 feet tall or taller than 35 feet. Oh, looks like they're taking into account the height of the sign. Alright, anyways, so that they do not interfere with power and phone lines. Write a compound inequality to represent the possible height of the poles. Now, you'll notice, one sign is not going to be both, okay? So, and in fact, the giveaway was they even used the word or right here. So that kind of made it clear that it was an or compound inequality. But even if you weren't sure, go ahead and just write down these results and you'll be able to tell your answer is going to be an or. And as a final thought part, I tell you the answer is that they're specifically asking about the height of the poles. Remember, we already know that the sign is 8. So basically, for the first one, the height of this pole, the maximum height, if we're going to be shorter, okay, is, remember, it's 20 feet total, but the sign is already 8 feet. So that means there's only 12 feet left for the pole. So that means the pole must be less than 12 feet tall. That's what they're saying. So our first inequality is the pole must be less than 12 feet tall. That's our first one. We then say, okay, or. Now, it has to be taller than 35 feet. Well, we know that, remember, for 35 feet, that's the total height, but we know the sine is 8. So that means the pole is 35 minus 8. Okay? So the pole for that one is going to be x is greater than 27. That would be an acceptable height for the pole. As long as it's greater than 27, we know that the sine would be nowhere near the power lines. Okay, guys? So basically, this was just an example of looking for one or the other. So make sure you have detailed notes. We've gone through examples of each. We've gone through some special combinations of each. And I even said, what if it was an and question? How would it have been different? So make sure you're trying to pick up on the difference between an and or an or. So one last time, compound inequalities are, there's two constraints, two restrictions. But whether if it's an and compound inequality, it has to satisfy both. Where does it set? Where on the graph, or just where in logic, would satisfy both inequalities? If it's an or compound inequality, it's whatever would satisfy either or. So whatever would work for the first one and whatever would work for the second one. So it's both combined. It doesn't have to be both at the same time, but it's either or. So you have more choices almost. All right, take care. We'll see you in class, and we'll take this to the next level.